So in this video, we'll be talking about specification-based testing or black box testing techniques. Right? Using these techniques, right? These black box testing techniques, techniques testers use, right? When they see the software as a black box, so that means they have no working knowledge of the internal workings of the software. They are only testing based on the software's behavior and functions perform. They don't know how it performs its functions. So both functional and non-functional testing can be a type of black box test. They can categorize as black box testing techniques. So specification is also called specification-based testing technique because it uses the specification of the software specification documents, right, as a point of reference for data selection and adequacy, right. The specification can be anything from a written document, collection of use cases, models, prototypes, etc. Right. So we have a few types of specification-based techniques or black box testing techniques. Starting with equivalence partitioning, right? So this equivalence partitioning technique, it divides the input of the data of the software unit into partitions of equivalent data from which test cases can be derived. Right? That's equivalence partitioning. Right? So let's say, for example, we want to test a text box that is supposed to take age as the input. Right? It's supposed to take an age range from 18 to 60 years, right, as the valid input. So in this scenario, right, if you want to test the age range of 18 to 60 years, see if it's valid for that text box, you have about 45 numbers to check with, right? You have 45 tests. You want to also check the invalid inputs. Can be an infinite number of invalid inputs. Starting with the invalid inputs from 0 to 17, right? 0 to 17 would be invalid because text box is accepting from 18 to 60. Also, 60 upwards will be invalid also, and of course, there's an infinite number from there on out. So, what can be done in this scenario is to test with each one of the valid inputs and each one of the invalid inputs. So, you can test with each one of the invalid inputs from 0 to 17 and check the result. Right? Most likely, if one of the inputs from that range is used to test, it's assumed that the result will be the same for the rest of the range. So the same thing for the valid input. Test any figure between 18 to 60. Right? If the response gotten, right, will be assumed to be the response for any range of valid inputs. And the same thing we check for the invalid input after 60. And the response gotten will be assumed to be the response that will be gotten for any range of inputs for that partition. So this is what is known as equivalence partitioning. This helps us reduce number of test cases we run, right? Knowing that we don't have time to run all the whole range of tests, right? As regards that test data. So it helps us to cut down the number of test cases we run to be more effective, right? So that's one thing. That's equivalence partitioning. That's the test technique called equivalence partitioning. Almost everybody probably uses it today, but you probably don't know that they are using the equivalence partitioning technique. There's also boundary value analysis technique, right, in which the tests are designed to include representatives of boundary values in a range, right? Include so let's say, for example, the testing that let's go back to our date, time, and let's go back to our age text box. We're testing that the text box can take 18 to 60, right? We want to test along the boundaries of 60, 61, 59, 59 and a half. Right? We want to know if we're taking the boundary values, boundary values in that range, and using it to run tests to compare results. So basically, that's that will sum up boundary value analysis, right? So we also want to look at decision tables, right? It's a technique in which tests are more focused on business logic or business rules, right? A decision table is a good way to deal with a combination of inputs. So using that technique, yeah, focusing on business logic, or the business rules regarding that software application. Yeah, so that's decision table technique. And there's also state transitioning testing technique, right? Right. Using this technique, right, the system is defined in terms of a finite number of states, and the transitions between the states is governed by the rules of the system, right? So system is defined by a finite number of states. It can be in a finite number of states at any point in time, right? And the transition between these states is governed by the rules of the system. Typically, these rules for which the system will change states has been documented somewhere, and you are checking that system changes its state based on these set rules, right? So that's a sum up of states transitioning testing technique. So that's it for specification based or black box testing techniques, right? And I'll see you in the next video.